Hello viewers, this is Ronald taking you through the story of A-level subsidiary mathematics. And this video we're going to go through the topic of two-dimensional vectors. So this topic is suitable for students in both senior 5 and senior 6 offering subsidiary mathematics. So just start with vector arithmetic. So this is just a review of what you already covered in O-level math under vectors. So we shall go through it still. So this involves addition, subtraction, and scalar multiplication. So to add or subtract two vectors, corresponding components or components in the same direction are respectively added or subtracted. So this is the same way you used to add and subtract vectors, and also scalar multiplication. So to find the scalar multiple of a vector, each component is multiplied by the scalar. So each of the components is multiplied by the scalar. So with that, let's go through this question. So question 1 says, given vector A, which is that, and vector B, which is that, determine the values of A plus B, then A minus B, 4A plus 3B, then negative 3A minus 2B. So you start with A plus B. So A plus B, remember, as we are working out, it's advisable to express your vectors in column form. So this is vector A, which is negative 1, 2, which is that in column form. Vector B is 4, negative 5, which is that. Now I'm adding, we add the corresponding components. So negative 1 plus 4 gives you that, which is in the end gives you 3. Then 2 plus negative 5 gives you that, which in the end gives you negative 3. So basically that's what they wanted. Now for part B, they wanted A minus B. So do the same. This minus this gives you that, which in the end gives you negative 5. And this minus this gives you this, which in the end gives you positive 7. So next is 4A plus 3B, which is that. So 4 is there, and A is that. 3 is there, and B is that. So like I said, this 4 multiplies each entry inside here, and this 3 multiplies each entry inside. So let's begin with the upper part. So for the upper part will be 4 times negative 1, which is negative 4. Then 3 times 12 times 4, which is positive 12. And in the end gives you positive 8. Then for the downer part, 4 times 2 gives you positive 8. Then 3 times 5, negative 5 gives you negative 15. Then in the end you get negative 7, which they want. And lastly we have negative 3A minus 2B. So negative 3 times negative 1 gives you positive 3. Negative 2 times positive 4 gives you negative 8. That is for the upper part, and in the end you come up with negative 5. Then for the downer part, negative 3 times positive 2 gives you negative 6. Negative 2 times negative 5 gives you positive 10. And in the end, we come up with positive 4, which they want. So basically, that's what they wanted. Now let's see how marks can be awarded. So M1 is for substitution, and the output, substitution, output, substitution, output, substitution, output. So that has been vector arithmetics. Now we shall go to midpoint of two position vectors. So suppose that OA and OB are position vectors of points A and B respectively. The position vector of OC is of the midpoint of AB can be got as follows. So if it is the midpoint, it means that AC is equal to CB. But we know that AC is equal to OC minus OA, and CB is equal to OB minus OC. Therefore, when I collect terms, bring this one this side to come up with 2OC, and take this one this side to come up with OA plus OB. But I want OC alone, so when I make OC the subject, it will be a half in brackets OA plus OB. So this is the formula to get the midpoint of our vector of two position vectors. So always remember that. Most students confuse it and put here minus, which is not okay. So that knowledge I'll go through question 2, which says that if OA is that 9,5 and OB is 14,10 are position vectors, find the coordinates of the midpoint AB. So the first thing to do is to state the formula for midpoint, then we substitute for OA and OB, then we simplify this plus this gives you this, which is 2315, but there is also a half which is maintained. Then after that we put this half to multiply by each entry inside to come up with 11.5, 7.5. But remember the question wanted coordinates, so shall come and write in coordinate form that the coordinate of the midpoint is 11.5, 7.5. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for substituting, M1 for simplifying the box bracket, B1 for output, and A1 for setting the coordinates. So that has been midpoint. Now shall go to magnitude. This is all review because we already covered them in O level. That is why I'm moving through fast. So magnitude of a vector is denoted by the symbol this. So two vertical lines denote magnitude. For example, if I write this A tilde in this vertical lines in bit enclosing it, it means that the whole of this means magnitude of A. Therefore, if vector A is P2, then its magnitude will be equal to this squared plus this squared, everything under square root. Now another word to mean magnitude is length of a vector or modulus of a vector. So they can either tell you to find magnitude of a vector, or they can tell you to find the length of a vector, or they tell you to find the modulus of a vector. So all these three mean the same thing. So let's go through this question. So question 3 says, given that vector A is 1, -2, vector B is 3, -1, vector C is 1, 2, find the length of vector 5A minus B plus 3C. So they want the magnitude of this vector. We are going to first simplify that, then after that we shall get its magnitude. So first we shall substitute for A, for B, and for C. Next is scalar multiplication. This 5 multiplies each entry inside to come up with that, and this one multiplies each entry inside to come up with that. Then next we shall simplify. Oh, this minus this plus this gives you this, and this minus this plus this gives you that. So next is to get the length. So length is magnitude of this, which will be 5 squared plus -3 squared, everything under square root, to come up with root of 34, which is equal to 5.8310 units. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for this substitution, M1 for scalar multiplication, B1 for the output vector, M1 for this substitution, and A1 for the output. So now we shall go to question 4, and question 4 says that if R is a vector such that R is equal to C plus lambda A in brackets A minus B, where A is that and B is that, then C is that, and magnitude of R is 10, find the possible values of the scalar lambda. So lambda is a constant. So the first thing to do is to write the given equation, and then we substitute for what is given. So we are given that C is 3/4, so we shall put there C for C. Then A is -2/4, so come and substitute for A. B is -5/10, come and substitute for B. Then when I simplify what is in this box bracket, I'll come up with 3 and -6, because -2 plus -2 minus -5 gives me +3. 4 minus 10 gives me -6. So when I combine these ones into one, I'll be able to get 3 plus lambda times 3, which gives you 3 plus 3 lambda. Then 4 plus lambda times -6, which gives me 4 minus 6 lambda. But I was told that the magnitude of magnitude of r is 10. Therefore, magnitude of this vector will be got by squaring this first upper part and also squaring the lower part, then put it under the square root, and it's equal to 10. That is why you put 10 here. Then to remove the square root, I have to square both sides to come up with that. Then when I open brackets, I'll come up with that. And when I collect like terms, I'll come up with that. Simplify further to come up with a quadratic equation. Then I can solve it, so I can still reduce this and that, this and to gives me that. So dividing 12 by 15 gives you that. Then I can use any method, either factorization or bulldozer, to come up with the value of lambda. So lambda will be equal to 5/3 or -1. So that's what they wanted. Now let's see how much can be awarded. So M1 for substitution, B1 for the output vector, M1 for substitution, M1 for expanding, M1 for quadratic equation, which is here, M1 for solving, and A1 for both values of lambda. So now shall go to question 5, which is that given that A is that, B is that, and magnitude of A plus B is 5, find the possible values of X. So we shall have to first get A plus B, which is that, X plus 1 and 3 here. But they told us the magnitude is 5, so I have to get the magnitude of this vector, which will be equal to X plus 1 squared plus 3 squared under square root. Then, like we did in the previous example, to remove the square root, I have to square both sides. Then I open brackets, collect like terms, and then solve the quadratic equation, and the values of X will be -5 and 3. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for the substitution, B1 for the output vector, M1 for substitution, M1 for expanding, M1 for solving, A1 for both values of X. So now we shall go to parallel vectors. So parallel vectors, if vectors A and B are parallel, it implies that A is equal to lambda B, where this lambda is a scalar. Now scalar is the word which is used to mean a constant value or a number. It can be a fraction or a whole number. For example, it can be a half, it can be a quarter, it can be a third, or it can be also be a whole number like 2, 3, 5, and it can also be positive or negative as long as it's a number and not a vector. So that knowledge shall go through question 6. Question 6 says, given that vectors A is given by that and B is that, find the value of t such that the two vectors are parallel. So with that we have to remember that for vectors to be parallel, A must be equal to lambda B. Therefore come and substitute for A and for B, then this scalar. When two vectors are equal, it implies that the components can be equated. So the upper part it will be 2 will be equal to lambda times 3, which gives you 2 equal to 3 lambda. And with this I can make lambda the subject, which will be 2 over 3. That was the upper part. Now I'll go to the lower part, which will be 6 equal to lambda times t. But I know the value of lambda is 2 over 3, so I'll come and substitute and remain with t as the only unknown. Therefore t will be equal to, so when I cross multiply, it will be 18 equal to 2t, and t will be 9. So that's what they wanted. Now let's see how much can be awarded. So M1 for this substitution and M1 for this equating, B1 for the value of lambda, M1 for this equating, and A1 for the value of t. So now shall go to collinear points. Like I said, this is just revision. That is why you are going fast. So collinear points, if 3 points A, B, and C are collinear, then it implies that AB is equal to lambda BC. Now this condition is somewhat similar to that for parallel lines, but what makes it different is that for collinear points there is always a common point to both lines. So this condition is for parallel lines, but also you have to make it collinear, you must add on this part of there being a point which is common to both lines AB and BC, as we are going to see in this question. So this question says points A, B and C have position vectors this and that. Show that points A, B, C are collinear. So we have OA, which is that 5, 2, OB, which is negative 3, 4, OC, which is negative 7, 5. Then we shall say that AB is equal to OB minus OA. So when I subtract, I'll come up with negative 8, 2. Then BC is equal to OC minus OB. When I subtract, I'll come up with negative 4, 1. So before we go to the next slide, let's see how marks can be awarded for this slide. B1 for that and B1 for that. So now that you have got AB and BC, we shall have to remember this condition for collinear points. So I say that for collinear points, AB is equal to lambda BC. So I come and substitute for AB and BC. Then I have to get lambda using the upper part, which is 2, and also get lambda using the lower part, which is also 2. Now scalar means constant. Now if you look at these two values, they are the same. If this was 2 and this was 3 or any other value, it implies that lambda is no longer a scalar, is no longer constant, meaning the points are not collinear. But since lambda is constant, it implies that this condition has been fulfilled. Therefore, next is to conclude. So you come and conclude that since AB is equal to 2BC, now where are these 2 coming from? This 2 is because this was lambda and we have got lambda as 2, so we have to come and substitute there. Now the conclusion must be complete. You must talk about this and also talk about a common point to both lines for the conclusion for collinear points to be complete. So basically that's what they wanted. Now let's see how marks can be awarded. B1 for this part, B1 for this part, and B1 for conclusion. So that has been revision of what you covered in O-level. Now we are starting something new which you didn't cover in O-level, but it's on syllabus of subsidiary math. And this is called dot or scalar product. Dot product or scalar product of two vectors. So you have said that consider two vectors, vector A which has these values and vector B which has these values with directions as shown below. So those are the two vectors, vector A and vector B. So vector A, vector B, and this is the angle between the two. So this dot product is mainly used to find the angle between two vectors. So you come and say that the dot product of vectors A and B is defined as A dot B. Note this there is a dot here. Now just like the word is, if this dot is not visible, then you have disrupted the formula. So as we are stating this dot product, make sure that your dot is visible and the dot is between two vectors. That's why you realize that here between this and this there is no dot in between, because these are not vectors, they are magnitudes or they are scalars. So it is A dot B is equal to magnitude of A multiplied by magnitude of B multiplied by cos theta, where theta is the angle between the two vectors. So I believe you know how to get magnitude of A and magnitude of B, but the challenge would be on how to get this A dot B. So A dot B, just like we said, the dot must be visible, the dot must be visible. And for vectors, we don't use the word multiplying vectors, we use dotting. So we dot two vectors, but that dot means multiplication. For example, how do they multiply? We will say this multiplied by this, and it gives you that. Then you say plus, then you go the downer part, this multiplied by this, you put it there. So that is what they mean by dotting two vectors. Magnitude, I believe you already know, this squared plus this squared. Therefore, when you know this and you know this and you know, it means that you can be able to get theta, which is the angle between two vectors. So the dot product is mainly used to get the angle between two vectors originating from a common point. I think you realize that these arrows are originating from a common point, which is O. So with that knowledge, you shall go through this question. So question 8 says, find the angle between the vectors A, which is that, and B, which is that. So we shall go through all the procedure for dot product. So first of all, you have to get the magnitude. So magnitude of A will be 3 squared plus 1 squared, everything under square root, to come up with 10. Then magnitude of B will be 2 squared plus 4 squared, to come up with the square root of 20. Then you have to dot A dot B will be equal to that, because this times this is 6, then plus this times this, which gives you 4. Then when you add these two, I'll come up with 10. After that, I'll be able to state the dot product first, and after setting it, I'll be able to substitute. A dot B is 10, and magnitude of A is root 10, magnitude of B is root 20. So with that, I have only theta, which is the only unknown. So I have to first make cos theta the subject, and to be that. Then at the end, I'll say arc cos to give me the angle, which will be 45. So basically, that's what they want. Now let's see how much can be awarded. So B1 for this, B1 for that, B1 for that, B1 for substitution, and A1 for the angle. So now shall go to question 9. Question 9 says, in a triangle ABC, the coordinates of the points A, B, and C are these ones respectively. Then use dot product to find angle ABC and hence determine the area of triangle ABC. So we shall first make a sketch of the triangle ABC. So the angle they want is at vertex B. When you look at this order, what is in between here is where the angle lies. So the vectors used must be originating from a common point. So we shall use vector BA and vector BC. So let's first get BA. BA is equal to OA minus OB, which gives you -5, -12. And vector BC is equal to OC minus OB, which gives you 8, -12. Then we also have to get their magnitude. So magnitude of BA, this should be BA. So big A is equal to 13. And magnitude of BC is square root of 208. Then the dot of BA dot BC will be this, and this gives you -40. This and this gives you +144. So when you add the two, you come up with 104. So before I go to the next slide, let's see how much can be awarded for this slide. So B1 for that, B1 for that, B1 for this, B1 for this, and B1 for that. So we shall come and state the dot product, and after that we shall substitute for BA dot BC, magnitude of BA, magnitude of BC, and we remain with theta as the only unknown. So when I simplify, I'll come up with cos theta being equal to 0.5547, and when I use arc cos that, it'll come up with 56.31 degrees. So now we shall go to the hence part. Hence part, they wanted the area. So area is given by the formula. When you have two sides and the angle enclosing the two sides, we shall use this formula for a triangle, and it is a half BA, which is one side, BC, which is another side, and sine theta, which is the angle enclosed by the sides. So I know that magnitude of BA is 13 and magnitude of BC is square root of 208 and theta is 56.31. So when I substitute, I'll come up with area being equal to 78 square units. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for this substitution, A1 for the required angle, M1 for this substitution, A1 for the required area. So now we shall go to question 10. So question 10 says the position vector A and B are this and this respectively. Find 2A plus B dot B, and then find the angle between 2A plus B and B. So first of all, we are going to first find 2A plus B. So we substitute for A and for B and these two there. So in the end I'll come up with 77. Then magnitude of 2A plus B will be this squared plus this squared, everything under square root, to come up with square root of 98. Magnitude of B will be this squared, because B, this is 1 here and also 3 there, so it will be that. Then the dot which they wanted here, 2A plus B dot B, will be, I'll substitute 2A plus B is 77 and B is 13. So when I dot the 2, I'll say this multiplied by this gives you 7 plus this multiplied by this gives you 21. So when I add the 2, I'll come up with 28. So that is what they wanted. Now we shall go to the hence part, but before I go there, let's see marks for this slide. So M1 for substitution, A1 for output, B1 for that, B1 for that, and B1 for that. So from dot product, we shall say that that is a dot product. Then we shall substitute. This is that, this is that, this is that. Remain with theta as the only unknown. So when I simplify, cos theta will be equal to 0.8944. Our cos that will be 26.57. So basically that's what they wanted. Now let's see how much can be awarded. M1 for substitution, A1 for the angle. So that has been dot product. Now we shall go to perpendicular vectors. So perpendicular vectors, still, if two vectors A and B are perpendicular, it implies that the angle between them is 90 degrees. Therefore, from this dot product, where there is theta, you will put there 90 degrees. But what we know, when you use a calculator and press cos 90 degrees, you find out that the answer will be 0. So when I put 0 here, the whole of this becomes 0. Therefore, you'll come up with A dot B being equal to 0. Now, this is the condition for perpendicular vectors. As long as two vectors are perpendicular, it implies that when you dot those two vectors, the outcome is 0. So that knowledge, you shall go through this question. So question 11 says, given that vectors A is that and this should be B, so you change that is B is that. Show that A and B are perpendicular. So you come and remember that for perpendicular vectors, A dot B is equal to that. So you have to make sure that the output is 0. So when I multiply this by this, gives me that. This by this gives me that. So simplify, this is 16 and this is negative 16. So in the end it is 0. So since it is 0, we can conclude that this A dot B equal to 0 implies that the vectors are perpendicular to each other. So as long as two vectors are perpendicular, their dot must be equal to 0. So that's what they wanted. Now let's see how much can be awarded. M1 for substitution, M1 for dotting, M1 for output, B1 for conclusion. Now we shall go to question 12. Question 12 says triangle ABC has vertices that, and that. Use the product method to show that triangle ABC is right angled at vertex A. So we shall make a sketch of the right angled triangle. So the vectors to use must be originating from a common point. So we are going to use AB and AC. So AB is equal to OB minus OA, which is -4, -2. Then AC is OC minus OA, which is for -8. And AB dot AC gives me that. So this and this gives me that, and this gives me that. Then this is that, and then it is 0. Therefore, since this is equal to 0, it implies that triangle is right angled at vertex A. Right angle means 90 degrees. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for this, M1 for that, this for dotting, this for output, and this for conclusion. So now we shall go to question 13. Question 13 says, given that vectors that and that are perpendicular, determine the value of mu. So the good thing, we know the condition for perpendicular vectors. So we shall say when they are perpendicular, when you dot them, you'll be able to get 0. So dotting means this times this to give me that, and this times this to give me that, equal to 0. So with that I have only one unknown, and when I make it the subject, it will be -1.5. So that's what they wanted. Let's see how much can be awarded. So M1 for this, and M1 for equating to 0, M1 for dotting, and A1 for the required value. So that brings us to the end of this video. Thank you for watching, and be reminded that the next video will be on arithmetic and geometric progression or series. So if you have not yet subscribed, please click on the subscribe button below this video so that you will receive updates when the next video on AP and GP is uploaded. Otherwise, thank you for watching, and also if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.